So we do another problem, that is s power 5, s power 4, 4s cubed plus 24 s square plus 3s plus 63 is equal to 0. Right. So we are going to find Routh stability criterion for this characteristic equation. Okay. So you just form Routh array formulation, that is, so this starts with the s power 5. So you have to take first write s power 5, s power 4, s power 3, s power 2, s power 1, s power 0. Okay. What is the odd powers of coefficients? 1, right? Here is 1 and 1 4 1 4 3 1, here 1 4 and here is 3. Okay. Then again you have to find the even powers of s. What are the even powers of s? Here 1 here and here 24 63, 24 and 63. So we have to find s power 3 coefficients. How to find this one? So you already know how to find this coefficients. Already I have told you how to find this all the coefficients. Okay. So we will do that one, how to find all these coefficients. So you see that here this one, right? Take this one, right? So this plus this is minus. Okay. So how are you going to do it? 1 into 24 . So see that this one is a minus and this one is the plus. Okay. So how are you going to do it? 1 into, so you are going to find s power 3 coefficients. S power 3 coefficient. So 1 into 4, 1 into 4, okay, minus 1 into 24, 1 into 24 divided by 1. How much you will get? So 4 minus 24 by 1. So you will get minus 20. You will get minus 20, right? Okay. Next, so this one would be minus 20. Next 1 into 3, then 1 into 63. So this will be minus. So next 1 into 3 minus 1 into 63 by 1. So you will get minus 63. So here minus 63. Now there are no coefficients to divide. This become, next this become 0. So now see here minus 20 is there, minus 60 is there. So this can be divided. This can be divided by 20. This can be divided by 20. Right? Divided by 20. Divide by 20. See, when you can divide in this row, if all should be divided, then you can divide. If one is divided and other value is not divided, so we should not divide. If all row elements are divided, then we can divide, right? So I'm going to divide it. 21 ja, it means minus 1. Okay. 20 minus, sorry, this is 60, this is 60, this is 60, so this become minus 3. So minus 1 minus 3, right? So now we will find the s power coefficients. S power coefficients. How to find s power coefficients? So s power coefficients, we are going to find s power s square coefficients. So how to find here? So minus 1 into 24, so 1 into minus 3. Okay, so minus 1 into 24. So as per the equation, already minus is there, so 1 into minus 3, so you have to divide by minus 1, right? So when you divide minus 1, so what you get? So minus 24, so minus plus, so that will be 3, that will be 3, right? So that you will get minus 24 minus into minus plus, this is a 3 by minus 1, so you will get minus 20, this is 20 minus 23 by minus 1, so this both gets cancelled, so you will get 23, so you will get 23, so you write here 23, right? So what is the next value? The next value is we have to find minus 1 into 63, minus 1 into 63, so this one minus 1 into 63. Okay, already, so minus is there, minus, so 1 into 0, 1 into 0 by minus 1, so how much you will get? You will get, so minus gets cancelled, this becomes 0, so you will get 63. So this is how much, this one is the 63, and this one also you can divide by 23, so divide by 23, so this can be divide by 23. When you divide by 23, so you will get 1 and you will get 1 here. Okay, now you find s power 1 coefficients. Find s power 1 coefficients. So what is s power 1 coefficients? When you find s power 1 coefficient, so what you get here? So 1 into minus 3, 1 into minus 3, right? So this is this should be 3, it's not a 1. Okay, so 1 into minus 3, 1 into minus 3, here minus, so already as per the equation minus, so minus 1 into 3 by 1, how much you will get? So you will get, this will become minus 3 plus 3, so what you get? By 1, so you will get, this is the 0, this is 0, so you will get 0. Again what happened? Next if you go 1 into next value become so 1 into 0, right? 1 into 0, then minus 1 to 0, this value also become 0. So here if you further we can apply Routh formulation, so what happen? You will get infinity, here. Right, how we can get the infinity? You just see here, so 0 into 3 minus 0 into 1 by 0, so 0 by 0, this is undefined, it means it is say infinity, undefined, this one. Okay, this value is undefined, so you can't go ahead. Okay, so means the Routh formulation is here, Routh stability criterion procedure is failed here, right? So what we're going to do here, so see this s power 1, all rows become 0, so you can't continue it now. If you continue, you got the infinity, right? So in this case what we have to do? In this case, so we have to take this we call it all zero row. This we call it all zero row. All zero row. This we call it all zero row. So now we can't go ahead. So what we have to do? Now we have to take. So here s power 1 row or become all zero. So what you have to take? S power this above 1 row. What is there? S square. So we have to take s square equations. So how we can take? We can take like this. So what is a s square equation? So the s square equation is so we say that s square equation, we say that's an auxiliary equation. We say that that is auxiliary equation. So it means, see, take s1 row above what is that? S square right there. So s square row, we call it that one, we call it auxiliary equation. Auxiliary equation. Generally we are going to represent a s auxiliary polynomial equation. So that is s square plus 3. S square plus 3. You just see here, how did I write here? So this row started with the s square. After s square, generally we will get coefficient, right? Coefficient. So s square coefficient, because this is we are taking this even powers of s. So first even power, what is that? S square. Next even is 3, right? Here s will not come. Okay, so this is the equation we got. Then next what we have to do? So we have to differentiate with respect to s. We have to differentiate with respect to s. ds by ds. Okay, when you differentiate, you will get 2s plus 0. 2s plus 0. Now we have to continue with this Routh array formulation. So here in s square row, you just take a s 2 and 0, right? So I am going to write again this formulation. So here I am going to write again s power 5, so s power 4, s power 3, s square, s power 1, right? And s power 0. So you know that what is s power coefficient? So you know we have done it all these things. So that is 1, 4, 3, then 1, 24, 63. So minus 1, minus 3 is 0. Next 1 is a 3. So then what is s power 1 coefficient here? Next 2 and 0, right? So then we can continue with the Routh array formulation. So now how can you do it? This one, so this one 2 into 3, right? So 1 into 0, right? So that you can do it. Okay, so how can you do it? So 2 into s1 coefficient, 2 into 3 minus 1 into 0, 2 into 3 minus 1 into 0 by 2. How much you will get? 6 by 2. So you will get 3. You will get 3, right? 2 into 3 minus 2. So you will get 3. So here, so this coefficient you will get 3. Okay, so now we have to examine first column of this Routh array, the first column of column array. So what is the condition to be stable? If all first column of all elements positive or there is no sign changes, so then we say it is a stable system. But here there are sign changes. How many sign changes? We will see that. How many sign changes? Here you see that plus, this is also plus here, this is also plus here. So what happened? This is also plus, this is also plus, this is also plus. How many sign changes? So plus 2 plus no sign change, plus 2 minus 1 sign change, and then minus 2 1, plus 2 minus, and minus 2 1, right? Again plus 2 plus no change, plus 2 plus no change. So here 2 sign changes. Here is a 1, okay, 2. So it means 2 sign changes means 2 poles are. So what I have explained last time, I told you number of sign changes is equal to, right, number of poles on the right up of the S plane. I have told you number of sign changes is equal to, okay, number of poles on the right half of S plane. How many sign changes here? 2. So therefore 2 poles on the right half of the S plane. So here is system is unstable. Here system is unstable. So 2 poles are lying right up of the S plane. Somewhere it is lying. So this system is unstable. The system is unstable because 2 poles are lying right up of the S plane. So the system is unstable. The result is the system is unstable. So next problem we are going to do it. Next problem is, you can write construct route array. Next problem, construct route array and determine the stability of the system. Determine the stability of the system whose characteristic equation is s power 6, right, 2 s power 5 plus 8 s power 4 plus 12 s power cube plus 20 s square plus 16 s plus 16 is equal to 0. Also determine the number of roots lying on right half of S plane, left half of S plane, and on imaginary axis. So what you have to find? First we have to construct route array. Next, determine the stability of the system whose characteristic is this one. And next also what we have to find? How many roots are lying left half of the S plane, and how many roots are lying right half of the S plane, and how many roots are lying on imaginary axis. So we do this one. So you just follow the route array formulation. So first, what is the characteristic equation? So what is the characteristic equation? The characteristic equation is, right, so s power 6, 2 s power 5, 8 s power 4 plus 12 s power 3, 20 s square plus 16 s plus 16 is equal to 0. 16 is equal to 0. Now we have to form Raut array formulation from this equation. So how do you going to form it? So you know that what is the even powers of coefficients? So that is s power 6. First write s power 6, s power 5, s power 4, s power 3, s power 2, s power 1, s power 0, s power 0, right? So now we have to write all the coefficients of even powers. Okay, what are the even power coefficients? So first here 1, then after that 8, after that 20, okay, and 16 and 16. Okay, then what are the odd powers coefficients? Odd power coefficients. So odd power coefficients are 2 here, and here 12, here 16, and next is 0. So we have to construct the Raut array formulation for this. Okay, so here you see one thing. So this row can be divided by 2, because all elements can be divided by 2, right? So here what happened? Here one element cannot be divided, so we should not divide this row, right? In this row all elements can be divided. Okay, so we can divide by 2, divide by 2. So when you divide 2 1 ja, okay, 2 6 2 18, 2 18. So now we form the Raut array formulation, construct it. So now we have to find all s power coefficients. To find the s power coefficients, what you have to do? So 1 into 8, 1 into 8, then 1 into 6. So when you take down one is take as a minus, and then upper one is take as a plus. Okay, so then we will divide by this element always. Okay, that we have to do it. So I'm going to find s power coefficients. So to find s power coefficients, what I do? So 1 into 8, 1 into 8 minus 1 into 6 by, we divide by this 1. So 1, how much you get? 8 minus 6 by 1, so that is 2. So we substitute here 2. Okay, then again 1 into 20, next 1 into 20, right? Then minus 1 into 8 by 1, so you get 20 minus 8 by 1, so that is 12. So you get 12. So this value become 12. Next what happened? 1 into 16, 1 into 16, then 1 into 0, right? 1 into 0, 1 into 16 minus 1 into 0 by 1, so you will get only 16. Okay, so this is 0. So next there is no element here, so this value become, this here become 0. So now this can be also divided by 2. So I am going to write this can be also divided by 2 here. This can be also divided by 2. So I am going to write the fresh sheet I will take and write here. So we know that s power 6, s power 6, s power 5, s power 3, s power 2, s power, sorry, this is s power 4, s power 4, s power s power 6, s power 5, s power 4, s power 3, s power 2, s power 1, 0. Right? You know this one 1, 8, 20, 16. Okay. Then after that, so this was 2, 2, and 12, 2, 12, 18, 0. So this was divided by 2, divide by 2. When you divide by 2, so you got here 1, you got 6, and you got 8. And after you finding, so you got here 2, you got 2, then 12, and here 16. So this can be also divided by 2. Divide by 2. So when you divide by 2, so you will get 2 and 1. So this is 6. Okay, this is 8. Okay, so what we have now, 1, 6, 8. Here also 1, 6, 8. So when you divide, what happens? This s cubed row become 0. You know that. Now we are going to find s cubed coefficients. Okay, when you find s cubed coefficients, so what happened? 1 into here 1 into 6, 1 into 6 minus 1 into 6 by 1. So what happened? This become 0. So this becomes 0. Again 1 into 8, again 1 into 8, 1 into 8 minus 1 into 8. So this become 0. So now what happened here? So s cubed row become 0. So how to go ahead now? So this row is 0. When this all zeros row is 0, so what is the procedure we have to follow? We have to take above this row, above s cubed row, what is there? S power row is there. So you have to take that one as the auxiliary equation. How we are going to take that one? So you just see here how we are going to take it. So AS means auxiliary equation. AS is equal to, so above this row s power 4 is there. So here is what is that? 1. Coefficient is 1 is there. So s power 4. Then after that, see 6s square. So what is this one? So this is, you have to take even powers of s. So first one is a s power 4, and the second is 6s square, third one is the 8. So this is the auxiliary equation. After this, what you have to do? You have to differentiate with respect to s. So differentiate with respect to differentiate with respect to s. So when you differentiate with respect to s, so what you get? Dy by ds. So when you get 4s cube plus 12s, this become 0. So you got 4s cube plus 12s. Okay, so then you have to continue this. Okay, you have to continue this. So in this place what you can write? So instead of 0, what is s cubed coefficient here in this row? 4. Here is the 4, right? Here 12 I am going to put. 12 I am going to put. Okay, right? 12 I am going to put. Again this can be divide by 4. So what happens? 4 1 ja, 4 3 ja, 4 3 ja. I'll take a fresh sheet so you can easily understand this. Okay, so I'm going to write here freshly. So what is that? S power 6, s power 5, s power 4, s power 3, s power 2, s power 1, s power 0. Right? You know this one is the 1, 8, 2, 20 and 16. So after dividing you got 1 6 8 0. So after dividing you got 1 6 1 6 8, okay, 0, right? Then after that what happened, this become all 0 rows. So after taking auxiliary equation and differentiating you got 4 4. I am write this one another color, that is a 4 you got 4 and 12 you got and 0. So this can be divided again, divide by 4. So how much you get? 4 1 ja 4 3 ja. So you can continue row array formulation. So now we have to find s square coefficients. To find s square coefficient, what you do? 1 into 6 1 into 6 1 into 6, then minus 1 into 3 by 1. How much you get? 6 minus 3 by 1. So you get here 3. You get 3. So here the value become 3. Okay, s square coefficient. And again 1 into 8 minus 1 into 0 by 1. So you will get only 8. So what you get? We get 8. Then s1 coefficient you have to find. What is s1 coefficient? 3 into 3 minus 1 into 8 by 3. So how much you get? Here 9 minus 8 by 3. It means here 1 by 3. So 1 by 3 value is how much? 0.33. So again further you calculate. So what happened? So this here s power 0, what is that? This will be 0. So 0 into 3 into 8, okay, minus 3 into 0 by 0.33. So what you get? So 0.33 into 8 by 0.33. So this both gets cancelled, so you will get 8. So this you get 8. So after this what you have to do? You have to examine first column of the element. So when you observe the first column, there is no sign change here. There is no sign change. Okay. What is the question they asked? So construct a row array. So we have constructed row array. Next what you have to do? We have to determine the stability of the system. Okay. So here what happened when you observe the first row? So there is no sign changes. All the positive, right? But the row with all 0 indicates the possibility of roots and imaginary axis. Hence the system is limited or marginally stable. So now we have examined here. So as per the statement, there is no sign changes in the first column. So what happened? The system is stable, but in between we got auxiliary equation. It means all 0 rows become 0, right? So from there we have to find the roots. So how we are going to find the roots for that? So you take an auxiliary equation. So in the question also we have given what the question is given. You have to find in the question you have to find also determine the number of roots lying on the right half of the S-plane and the left half of the S-plane and on imaginary axis So to find that, so you take auxiliary equation. What is your auxiliary equation? So your auxiliary equation is so this one is your auxiliary equation. You got this one, your auxiliary equation, this one. Okay, take auxiliary equation. Okay, so from what is your auxiliary equation? So your auxiliary equation is AS is equal to S power 4 plus 6s square plus 8 is equal to 0. Okay, this is the auxiliary polynomial. This is a polynomial equation. Okay, so now what you have to do here, you have to find the roots for this. So what I'm going to do, I'm going to put s square is equal to x. So it will be simple. So when s square is equal to x, then what happens? This become x square, this becomes 6x, this become plus 8. So what are the roots for this? So if we just calculate, so you find factors, so it's very difficult to find, so we have to apply the quadratic equation. After applying quadratic equation, so what is that? X is equal to minus 6 plus or minus, this is a, plus or minus b square means 6 square minus 4ac, 4a, a is 1, c is 8, okay, by 2a, a into a is equal to 1. So then after you get x is equal to minus this value you get minus 3 plus or minus 1. So what are the roots you got? The roots you got, so one is minus 2 minus 4, minus 2 minus 4 you got, okay. The roots are minus 2 minus 4. So you know that s is equal to here x square is equal to x, right. So what happened? S square is equal to, so first root, so you put minus 2. So then what is s? Plus or minus 2j, plus or minus 2j. Okay. So another root, s square is equal to minus 4. So s is equal to plus or minus, this one is the root 2. So this one is 2j. Okay, so we got from this equation we got two roots. One is, so s1 is equal to root j, and another s2 is equal to minus root j, and from this equation s is equal to minus 2j, s3 and s4 is equal to plus 2j. So there are four roots. So these, how many roots are lying left of the s plane? How many roots are lying left of the s plane? So you just see that as per the first, when you examine the first column, so there are no sign changes. But what happened? There is all zeros become 0. Okay. So from that we got auxiliary equation. From this auxiliary equation we have found some of the roots. So these are the roots. So in these roots means, see, in these roots, how many roots are locating an imaginary axis? Okay, so here first one root here, root j, okay, and minus root j, and another one 2j minus 2j. Okay, then rest of the poles are lying left half of the s plane. Rest of the poles are lying left half of the s plane. So this system is marginally stable. So how many poles are lying left half of the s plane? 0. Sorry, left of the s plane how many is lying? So we can see here so the system is actually marginally stable. The system is marginally stable because there is no pole is lying right up of the s plane. Okay, so we see that the results. We see the results. So what is the question we were asked to say? So the question is that was to determine the stability and also determine how many poles are lying left half of the s plane, right half of the s plane and imaginary axis. You just see that your route array, how many are there here? First column of the elements. So 1, 2, 3, 4, 5, 6. 6 rows. 6 rows. Out of 6 rows, how many rows are lying on the imaginary axis? 4 rows are lying on the imaginary axis. Okay, it means Then how many roots are lying right of the S plane? There are only 2 roots are lying left of the S plane. In the right of the S plane, 0. Okay, once again I repeat here. So how many poles are there? 1, 2, 3, 4, 5, 6. Out of 6 poles, 4 poles are lying on the imaginary axis. How many poles here? 1, 2, 3, 4. So then how many poles are left? 2 poles are left. Then the rest of the 2 poles are lying right above the S plane, but we don't know the location, but they are lying left of the S plane. Then what are the right above the S plane? There is no pole lying right above the S plane. So we write here conclusion. Here I am going to write the conclusion for this. Conclusion I am going to write here. From this I am going to write conclusion. My conclusion is the roots of auxiliary polynomial are also roots of characteristic equation. You see, the roots of auxiliary polynomial are also roots of characteristics. What are the roots of auxiliary polynomial? These roots, 4 roots, are the auxiliary polynomial. So these roots of the auxiliary polynomial are also roots of characteristic equation. We got 4 characteristic equations. We got the 4 roots from the characteristic equation. Okay. So that's next. So hence 4 roots. Hence 4 roots are lying on imaginary axis, and the remaining 2 roots are lying on the left half of S plane. I would like to repeat again. See, the roots of auxiliary polynomial are also roots of characteristic equation. So what are the auxiliary equation? From the auxiliary equation we got 4 roots. That 4 roots also part of characteristic equation. Okay. Hence 4 roots are lying on imaginary axis. Hence means this is a 4 roots. One is a minus plus root j. Okay. Another one is minus root j. Another one is root j. Another one is minus 2j. So these 4 roots are lying out of 6. 4 roots are lying on imaginary axis. Right. So another other 2 poles are lying on the right above the S plane. Somewhere they are lying. Okay. We don't know the location. So so there is no pole lying right above the S plane. Okay. So what happened? Now the system is marginally stable. So result I am going to write here. What is the result? So first question they asked whether system is stable or not, we have to determine. So the system is marginally stable. The system is marginally stable. So how many roots are on the right of the S plane? How many roots on the right above the S plane? Alright. How many roots on the left of the S plane? How many roots on the imaginary axis? So right side of the S plane, so 0. No pole is lying. So left half of the S plane, how many poles? 2 poles. On imaginary axis, and imaginary axis 4 poles. 4 poles. So this is the result, right?